Okay, so I increased the recording volume here. I don't know why it gets reset, but nonetheless, I'm sure the recording, I've checked every time I record, I check the sound. I have a lot of natural sound. Sometimes some kind of a moth starts making a lot of hissing sound, and as the sun is coming up, it's 10:45 a.m. and clouds seem to have moved. Sunlight is out, so it's getting hot here in Mumbai. So I have the fan on, so you will hear the slight hissing sound of the fan, and so on and so forth. Part of the global warming, kids. So let's continue to look at what happens with the warming as the land ice begins to melt. This is an interesting part, and intuitively you can think about this. Let's say I have a cup of water and it's too hot, so I put some ice in it. If the ice melts, the water doesn't increase because the ice volume is already in the cup. But if you melt the glacier that is on land and that water flows into the ocean, then it's not the same thing anymore. Remember, glaciers are built by snowing and snowing on top and snowing on top and so on for years, decades, centuries, and that means you are slowly taking water out of the ocean mostly and putting it onto land and building these massive volumes of glaciers which can be several kilometers high. When that glacier melts, land ice melts, that water is coming back into the ocean. So the ocean is regaining that water, which means it begins to rise, which we call sea level rise. Sea level is basically what you see when you go out to the beach or from the plane or in the movies and so on. Looks fairly flat, except there are some waves and so on. So slowly it begins to rise as the land ice begins to melt. And if you are living on the coast and the sea level is rising, then you will see the water is coming closer and closer to you, and the land is going underwater and so on and so forth. So when land ice melts, it runs into the sea. The additional water from the Arctic Ocean ends up flowing into all the oceans. This causes sea level to rise around the world. Again, we'll see some maps later on that because the earth is rotating and because there are winds that we have looked at before, winds can move the water around, so it's not like a bathtub that water keeps rising, which I'll show a little bit later with some figures. So on the average, levels have risen 8 inches since the early 1900s and about 2 inches since 2000. So the US is still using inches and miles and pounds and so on, and everybody else has moved on to kilograms and centimeters and meters and so on and so forth. But you know how to convert inches to centimeters, so you please do that as homework. So this is saying that it rose 8 inches since early 1900 and just since 2000 2 inches, which means, what does it mean? That means glaciers were melting. Now they are melting faster and faster, and water is coming into the ocean faster and faster. Sea level is rising faster and faster. But remembering that we are looking at the global average sea level rise. Sea level doesn't rise everywhere, as we will see in a minute, but it's still important to remember that as global warming happens, global sea level will rise because land ice is putting more and more water and the ocean is expanding. And if you warm the ocean, warm water also has higher volume, so sea level rises because of warming as well as changes in salt in the water and so on and so forth. Okay, so again, 8 inches doesn't seem like much, or 2 inches since 2000 doesn't seem like much, but these changes in the Arctic have an impact on the weather patterns for the entire planet. If you make the ice disappear in the Arctic, then it affects weather everywhere, including the monsoon here in India, even though Arctic is very far from the Arctic, because there are waves in the ocean, in the atmosphere, that can travel very far from one end of the world to the other, and they can change the circulation and the monsoon and so on. Okay, so it's like a teeny tiny spark that sets off a fire. When the fire grows, it can become monumentally large, hot, smoky, and so on. But all could have started with a tiny, tiny spark that you can barely see. In Alaska, coastal villages have already seen dramatic change. Homes are threatened by flooding and erosion, where water begins to wash away the soil and the sand. It's called erosion. Flooding is, of course, when you have a lot of water where you live and everything is going underwater, roads disappear, crops go underwater, and so on. That's water wearing away the shoreline. Sea ice is melting. So is permafrost, the permanently frozen soil just under the ground. The permafrost even feels different. It's springy, which causes houses to collapse into the water. So permafrost, if you have soil has some water in it, so soil moisture, or if you keep on making the atmosphere cold, it freezes. That's called permafrost. Permafrost, and high latitudes have lots of permafrost like Alaska. And permafrost is solid, it's frozen soil. If it begins to thaw because of the warming and it begins to be unfrozen, then it becomes soft and can be pushed down, which is what is happening. We'll see some cute houses in Alaska which have sunk because the permafrost has thawed under their feet and the house has become like a crooked, roads have collapsed, and so on and so forth. And when you walk on permafrost, it's like solid rock, but when it melts it becomes squishy, springy, spongy, and so on. And it has lots of gases stored in them like carbon dioxide and methane, which begin to come out of the soil. And remember, these are greenhouse gases. We already recorded this in the previous sections that you can go back and listen to. Greenhouse gases are the blanket that are trapping the thermal energy going from the earth to space, and that makes it warmer. So if permafrost is thawing and is releasing greenhouse gases, then it gets even warmer. That makes it will melt more permafrost and more glaciers, and this is why the melting is accelerating. So if you perturb something and it gets worse and then comes back and increases the initial perturbation, if you don't understand what that means, if you are too young, don't worry about it. These are called positive feedback loops or vicious circles, as we will see later on. Okay, some small thing will make things worse and worse. That is a vicious circle or positive feedback. Here is the permafrost frozen soil on which some shrubs and vegetation has grown, and below that, if you go deep enough, there is unfrozen ground because the heat and the cold do not go too far down. At some point you get the natural unfrozen ground. Of course, if you go deep enough, you get other Earth's geology happening. So you can see that the house here, the permafrost thawed and soil became completely soggy and became soft, and the house just collapsed. This is not good news. So I'll come back and show some images of collapsed or houses that have become dinged in the middle. People sitting there and watching TV in this house that has become a funny shape because the permafrost has thawed. So we'll see that in the next podcast. Okay, continue the discussion on things are heating up, and we are looking at impacts of the heating up here. When we say glaciers are melting, sea level is rising, permafrost is thawing, houses are collapsing, and so on and so forth. So you can measure the changes in temperature and rainfall and snowfall and the glacier volume. You can also look at the impacts on houses collapsing and other things. As we will go forward, we will do that. Okay, see you in the next podcast.